Okay, on to question 4. Consider the curves y equals the natural log of 12 minus 3x and y equals x between 0 and 4. Let their point of intersection be x equals beta. Show that this is between 1 and 2. So on a question like this, it looks a bit like a change of sign question. So there's a few ways we could do this. If we wanted to say, as you can see in the picture here, that this natural log curve is above the blue curve to the left, instead of working all of this out, what I could actually do is I could do the natural log of 12 minus 3x minus x. Yeah, sort of like the curve above. So this is like the above curve, and then this is the y below curve. And if I get a change in sign of this, it means that what used to be the one that's above to the left would now be, yeah, so it's like positive if you like, would now be the one that's below because it's negative. So that's one way that you could sort of work this out that I might suggest that you do. So if we substitute these values in, then we're going to get what? We're going to get the natural log of 12, let's do the 1 first, 12 minus 3. So in other words, the natural log of 9 minus 1. And if I work that out, I get 1.1972 or something. Let's do the other one. So if I do the other one, I'm going to get the natural log, what's this? The natural log of 12 minus 6, take away 2. So that's the natural log of 6 take away 2, which is natural log of 6 take away 2 is in fact a negative number. So that's minus 0.2082. Okay, there's a change in sign for the difference. So beta is between, there's a change in sign of difference. Beta is between, I might even, if you really want to add, just to be safe, it's a change in sign of the difference and they are continuous functions. Okay, beta is between 1 and 2. So that would be a very sure way of getting the mark. So now we've got an iteration. So iterations, that sort of makes sense because it's coming from using these things together as a way of solving. We've got an initial value of 3.4 and we're meant to use a diagram to look at what's happening. Decide if this iteration will converge. So I'm going to draw a cobweb and then we're going to say what actually happens. So the way it's going to start off is it's going to start off at 3.4, which is about here. It's then going to go up to the curve, the natural log, and it's going to sort of read off the value, which is about here. Okay, so you have a vertical line from the starting point, followed by a horizontal line that goes back until we get to the other one. Then what do? Well, when we get to this point, we draw another vertical line. We're going to repeat the process more or less that we just did. So a vertical line up into the interesting curve, and then across to get until we get to y equals x. And that's pretty much how this is always going to work. So let's do the next part. So the next part would go up to here. So until you hit the interesting curve, and then you go horizontally until you get back to sort of the boring curve, y equals x. And if we keep following this pattern, can you see that we are, in fact, going to converge? So it is a cobweb. Yeah, it is a cobweb diagram. Use cobweb or staircase on the graph to decide if the iteration. Therefore, the iteration converges to B. Sometimes this wouldn't happen depending maybe on like the shape of the graph or the starting point or something like that. But it does converge, and more to the point, it converges to C between 1 and 2, which is beta, which is the right one that we were looking at before. Okay, so an iteration question for our fourth question.